Okay, today we're going to have a look at changing the subject of a formula. So a formula can be something like Einstein's famous formula E equals mc squared. Speed equals distance divided by time. This formula, it allows us in practical terms to actually work something out. We're going to work on changing the subject of the formula by using addition and subtraction, multiplication and division, and squares and square roots, and that will become apparent to you as we move through the examples. Just for a warm-up, have a little go at solving that equation. Write down that equation, solve it. Technically, what's the method for solving this equation? Subtract 2 from both sides. Subtract 2 from both sides. That leaves us 4a on the left hand side, and it leaves us with 8 on the right hand side. Divide both sides by 4, leaves us with a equals 2. What have we done to solve for a? We've got a on its own, and that's the key when we're looking at changing the subject of a formula. This is solving an equation, get the a on its own. That allows us to produce a value for that variable a. Slightly more complicated equation to solve. We want to get the a on its own again. We start off by subtracting 2 from both sides. So on the left hand side we're left with 5a, on the right hand side we're left with our 3a plus 8. But we've got a's on both sides, so now we subtract 3a from both sides. That leaves me with 2a on the left hand side, and that leaves me with just 8 on the right hand side. Divide both sides by 2, and we get a value for a, because we've got a on its own. A equals 4. C squared equals 25. You can probably see the solution straight away. What do we technically do? We square root both sides, because we want to get that c on its own. To get c on its own, we find the square root of c squared, which is c. Got to do the same thing to the left hand side and the right hand side. Square root of 25 is 5. So c has got a value of 5. Speed equals distance over time. That's something I talked about earlier on. Speed and distance and time, they have a relationship. Speed equals the distance divided by the time. So if you travelled 100 miles in 1 hour, that'd be 100 divided by 1. 100 miles per hour. If you travelled 100 miles in 2 hours, you've travelled 50 miles per hour. If you travelled 100 miles in 4 hours, you've travelled at 25 miles per hour. What would happen if instead of knowing the distance and knowing the time, you wanted to find the speed? Oh. So, what would happen if they said, well, you travel at 20 miles an hour for 5 hours? Mostly you can see that if you travel at 20 miles an hour for 5 hours, so each hour you travel 20 miles, your total answer is 20 times 5, which gives you 100 miles as to what you've travelled. What you've done is you've taken that speed equals distance over time, and we've changed that to say the distance equals speed times the time. What do we do to both sides to get that d, that distance on its own? We multiply both sides by time. So that means on that right hand side, that time and that time cancel out, just leaving me with distance. And on the left hand side here we've got speed times time equals the distance, which is exactly what we used in that calculation. That is what changing the subject of a formula is all about, enabling us to use a basic formula and calculate the different variables within it. Key words. Variable, we know from our basic algebra. A variable is something like x, it's something like t. Something like x, it's something like y. Variables, letters, symbols. In both of these examples here though, that I've written, x is the subject because it's the variable that stands on its own. It hasn't got any numbers in front of it, below it, it's on its own. So x is the subject of that equation. X equals. Variable is any letter or symbol. Subject, x equals. We could make it t equals, we could make it y equals. That variable that stands on its own is the subject. So, how do we go about that? Make m the subject of the formula. This goes back to when you were solving those equations at the start of the presentation. What do we do to get that m on its own? The problem is we've got this -3, this -3 here. So, what do? We say we add 3. So that on the right hand side means we have achieved getting the m on its own. We've made the subject of the formula. But if we add 3 to the right hand side, you know from working out equations, we've got to add 3 to the left hand side. So we've now got t plus 3 equals n. Have we changed the subject to that formula to m? Yeah, we have. So m equals t plus 3. Job done. So it's just using that knowledge, your abilities about solving equations. How do we get that m on its own? Another example. Several examples here. It's asking you to make x the subject of the following equations. So what do we do here to get that x on its own? We subtract 2 from both sides, which means that y minus 2 equals x. Have we got the x on its own? Yeah, we have. Just rewrite it as x equals y minus 2. No problems with that. How do we get this x on its own? We add 5 to the right hand side, which means we add 5 to the left hand side. So b plus 5 equals x. Just rewrite that. The x is on its own. We've done what the question asked us to do. What about this one? Little variation in there, slight complication in there. We want to get the x on its own. So we could do it by saying, right, well, hold on, that's a negative x at the moment. So what we could do is we could say add x to both sides. So that means we've got c plus x on the left hand side, and we've just got the 1 left two stages there. It's about getting that x on its own. We've got to be careful. We don't want minus x on its own, negative x on its own. We want x on its own. So we've got to do something about that. Okay? 3 examples there for you. Right. Make t the subject of the formula. What do we do to get t on its own? We've got to get rid of that 4, haven't we? So, we do this. We divide both sides by 4. We divide both sides by 4. 4 on the top cancels with 4 on the bottom. That leaves t on its own. It leaves us with p over 4. So t equals p over 4. Those first few examples, we were changing the subject of the formula by adding and subtracting. We've just changed the subject of this formula by a little bit of division. Useful example. Stepping up a level here, this is an actual formula. It's one of the equations of motion. The v and the u stand for various speeds, velocities. S stands for distance, the A stands for acceleration. But that's not the important thing. You don't have to remember that at the moment. This is something that you will use in physics, and you will use it in maths as you move through to higher levels of maths. But it's asking us to make A the subject of the formula. So it's effectively saying we know this velocity, we know the other velocity, we know the distance. We're trying to work out the acceleration. We're trying to find the value of A. Okay? This is the real reason that we need to learn about changing the subject of the formula so that we can deal with these practical type situations as they arise. So, we're trying to get that A on its own. What's the first thing we do? We want to get rid of that u squared there. So we say minus u squared to both sides. So on the left hand side, we've got v squared minus u squared. On the right hand side, we're left with 2ax. Right. So, we want to get that A on its own. We've got to get rid of the 2, we've got to get rid of the s. So we divide both sides, it's got to be both sides, by 2s. So that means v squared minus u squared, that's all divided by 2s. So v squared minus u squared, all divided by 2s. The whole of that side's got to be divided by 2s. If you divide the right hand side by 2 and an s, it just leaves us with the A. And that's the job done. Right, in the subject of the formula. Okay, got a little bit of work to do here. I'm going to get rid of that plus 3, so we say subtract 3 from both sides. So c minus 3 is 2m squared. Okay, so far so good. Now we want to get rid of that 2. So we divide both sides by 2. Don't forget, it's all of the left hand side divided by 2. So c minus 3, all divided by 2. Is m squared. But we want to get m on its own. We want m being the subject of the formula. So that means you've got to square root both sides. Square root both sides to get that m on its own. Can we simplify that at all? We square root it. We don't know the value of that expression there, so the solution is just going to be left in that form. Don't be scared of that. There's nothing you can do to simplify that. That is your solution. Have we achieved what the question asked us to do? Have we got the m on its own? Yes. x, we've made it subject to the formula. Might look a bit cumbersome, a bit complicated, but we've done what we can. That is your solution. Okay. Let's have a little look at some examples for you to work through. So here's some examples for you. So it might want to be that you pause the presentation and you work through these examples. How are you going to do them? You might need to do a bit of division, you might need to be doing a little bit of addition, you might need to do a bit of multiplication. Make K the subject, get K on its own. Make Y the subject. Make P the subject. Make R the subject. Okay, so just follow the instructions for each one of these. So pause the presentation, write down your examples and work them through for yourselves. And then I'll come back with these solutions for you. Okay, there were your examples for you to have a go at. And there, ladies and gents, are your solutions.